All right, hey everybody, this is 7.2, Solving Systems by Graphing. So our last lesson we talked about graphing circles, so you're going to need that. If you haven't done 7.1, please go back and do that first. When we are solving systems, basically we're trying to find where they intersect. Okay, what do they have in common? So what we'll need to do is we'll need to graph our equations and see where they intersect. In order to do that, we probably should do a quick review of how to graph. When we're doing linear equations, all of your equations, as far at least for on your notes today, they're in slope-intercept form, where m is your slope and b is your y-intercept. Okay, so given the equation, all you need to do is plot the y-intercept and then use the slope. Okay, and we'll do some examples as we go along. Graphing a quadratic, I think all of your examples will be in standard form, which is y equals ax squared plus bx plus c. If it's in vertex form or intercept form, we also learned how to do that in Unit 6. So if you need to, you can go back to that, or I'll probably go over any of those on our notes today. Okay, but we have not ever learned how to graph from standard form. Okay, and I put the instructions on how to do that. So all you need to do is plot the vertex. Well, how do we find the vertex? Well, if you remember, we did the quadratic formula, and that was like x equals negative b plus or minus the square root of blah, 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 all over 2a. Okay, this is your axis of symmetry. And then we're basically adding and subtracting the same amount to both sides. That gives us the x-intercepts. So that's where this negative b over 2 comes from. So we will first, I guess I'll leave that. So first we're going to find the axis of symmetry. So I'm going to write that here, axis of symmetry, which gives us our x, which is negative b over 2a. And then to find the y, we plug this into our equation. Okay, and we'll do some examples of that. And then the last thing, oh yeah, so that gives you your vertex. This is our vertex right here. This is our vertex. And then we plot our vertex, and then we'll use the growth pattern, 1a, 3a, 5a. So you may need some help with that if you weren't here when we did this last semester. And then we are going to graph equations that are circles, and that's what we talked about last time. Again, h and k is your center, and y is your radius. So just your distance between. So for like this example, it looks like our center would be 0, 0, and our radius is 3. All right? Okay, so again, what we want to do for all of these is we're going to graph them, graph the equations, and see where they intersect, and we'll write down them as ordered pairs. Okay, so let's graph these two together. Again, these are linear equations, so this is like our slope. Our slope is 1. This is like our y equals mx plus b, and b is your y-intercept. So we'll plot our y-intercept at negative 2, and then our slope is up 1 over 1, up 1 over 1. Okay, and you'll just go all the way till you get out of your graph, and we'll do it in the opposite direction. Okay, so that's one of our equations, and we got to do the other one as well. So I'm going to do this one blue. This is our slope. This is our y-intercept. So our y-intercept is 4, and our slope here is going to be a negative 1. So we'll go down 1 over 1. And we'll just continue that pattern, both directions, connect all your dots, and we find that our intersection, or our solutions, is 3, 1. Okay, so this is part of your answer, and graphing each of your equations correctly is also part of your answer. All right, so here's another example. If you would pause and give that a try. So let's talk the top one. We'll have this be red again. We have a y-intercept at 4, but our slope here is down 2 over 1. So rise over run, down 2 over 1. In both directions. Connect your dots. As far as I know, all of your points where they intersect, when you have both of your equations and they intersect, they should be like lattice points where the lines cross. So it should be easy to find. Our other one is negative, our y-intercept is -2, and we're going down 1 over 2, down 1 over 2. Okay, and we see that they intersect. Just going to connect that over. And we'd say our solution here where they intersect is 4, -4. All right, if you have lines that don't cross at all, then we would say that there are no solutions, and you could say none. Okay? All right, so let's look at some other examples. Now we have a quadratic and a linear. So again, if we want to find the vertex from standard form, again, our x is going to be -b over 2a. So here, -b, b is 2, and here a would be 1. So we'll have -2 over 2 times 1, which is -1. And we'll take that and plug it into our equation to find y. So that would give us -1 squared plus 2 times -1 minus 2. And you could put that into your calculator if you wanted to, but I think you'll get 1 minus 2 minus 2, which will give us -3. So our vertex is -1, -3, and then we'll use our growth pattern. So it looks like we'll go over 1, up 1, over 1, up 3, over 1, up 5 on both sides. So if you need a review on how to graph, or like what the growth pattern is, just come and talk to me, or you could go to our previous videos from, I guess, unit 5 or 6. No, 4 or 5. Okay? All right, and then we'll do our other equation. Has a y-intercept at -2. Oop, looks like we already got where it hits. And it has a rise over run, up 2 over 1. Okay, and looks like it crosses one time at the point 0, -2. Okay. All right. Now let's see what happens if we do this equation. If you want to pause, it'd be great if you do that. So here we have, this is like plus 0, yx, or 3x plus 0. So our y-intercept is 0, and it goes up 3 over 1. So this is like 3 over 1. And we'll go the opposite direction, connect those dots. Sweet. And now we got to do our quadratic. So again, x is -b over 2a. Remember, x equals -b, and we're going to skip all that part all over 2a. Okay, so if that helps you, I don't know. Okay, you're also welcome to switch it into a different form if you'd like to, but I think a lot of you are sick of vertex form and all that, but you're welcome to switch it to vertex form if you'd like, or intercept form, and graph that way. So here we got b is 4 and a is 1. So we get -4 over 2 times 1, which gives us -2. And then we'll plug that -2 into our equation. We'll get y equals -2. Just make sure you use parentheses if you are putting in a negative. When you plug it into your equation, also use those parentheses. All right, and then if you do that, let's see what we get. So we get 4 minus 8 minus 2, so it looks like we get negative 6. So negative 2 comma negative 6 would give us our vertex. And then we'll just need our growth pattern. So again, A is 1, go over 1, over 1, up 3, over 1, up 5. Oop, and it looks like here this is where it crosses it twice. It crosses at the vertex and then also at 1 comma 3. So here is one of them and here is the other. So we've got 1 comma 3 and negative 2 comma negative 6. So here we have two solutions, two intersections. All right. Here's an example where it's not in standard form. We kind of learned how to do that, but if you wanted to keep going with standard form, all you need to do is distribute. You could x squared plus 1x plus 5x and then 5. So we get x squared plus 6x plus 5, and then you could do what we just did, but just to mix it up, I'll do it in intercept form. So we're going to graph. We have our y-intercept for the first equation is crosses at 1, and it goes up 2 over 1. And we continue that straight line best you can. Okay, and then if we want to graph from intercept form, again, x's lie, so our x-intercepts are going to be negative 5 and negative 1, and it has a growth pattern of a is 1. So we just kind of need to go backwards. It looks like it would be here. So it would go over 1 up 1, over 1 up 3, over 1 up 5. So it looks like here's another example where it only crosses at one location. And that would be negative 2 comma negative 3. Okay, I think I did that right. Sweet. Okay. All right. So there's lots of examples. I don't know that I'm going to go over all of these. Or you're welcome to kind of skip to this part if you need to. We have some circle equations that we haven't done yet. I'm probably just going to finish this up. So here we have two quadratics. This is the parent graph, which it just looks like this. Has a vertex of 0, 0. Okay, so that's kind of quick to do. Why don't we do that really quick? Again, if you wanted to do this whole thing where we did x equals negative b over 2a, well, b is 0, and a is 1, which is 0, and we plug that into our equation, y equals 0 squared, well, that's 0, so our vertex 0, 0. And we'll do the same thing for this one. Would say x is equal to b again is 0 over, I guess, negative 0 over 2 times a, which is negative 1. So that gives you 0. We plug that into our equation, negative 0 squared plus 8, which gives you 8. So our vertex here is 0, 8, but it's going to go down. So here is our vertex, and a is negative 1, so we'll go over 1, down 1, over 1, down 3, over 1, down 5. Wait, what did I mess up here? Oh, that's what I did. So this should be up one more higher. That's why I'm all messed up. Okay. And we'll do it on the other side. So I think already we can see where they intersect is at negative 2, 4 and 2, 4. So negative 2, 4 and 2, 4. And we're good. Okay, so let's talk about these circle equations. Let's make sure we got this. So we'll do our linear equation. This is kind of in the backwards order. This is typically negative x plus 4. If you have it in like slope or point slope, slope intercept form. So the y-intercept is 4, and it looks like we go down 1 over 1. So that's like a negative 1 over 1 would be our slope. Okay, so do your best. Put those points in. Don't just like do a nilly-willy straight line that's gonna not be where it's supposed to be. Kind of have it right if you're gonna do your intersections. All right, and now we have a circle equation. So again, we want to find our center. Our center here would be 0, 0, and a radius of the square root of 16. So remember, this is r squared. So our radius is 4. So we'll plot that, our center, and then we'll go 4 in north, or up, down, left, right. And it looks like we have our, that's a really bad circle. That's not great either, but okay. So we see our our intersections. One would be 4, 0, and 0, 4. Okay, so if you want, pause, give this one a try if you'd like. I'm going to try and give it a try too. Okay, and then we have our circle equation, which looks like we have a center at negative 3, 2, and a radius of the square root of 4, which is 2. So negative 3, 2, and then we will go 2, up, down, left, right. And same sort of thing, it looks like it crosses twice. And our solutions would be negative 5, 2, and negative 3, 4. Okay. All right, so that's that. You'll have all those types of those problems. Okay, one thing we want maybe quickly talk about is the different types of solutions. Okay, so I'd love it if you would pause and kind of write down some that you can think of or draw them. But like no solutions would be an example where we have maybe 2 vertical lines. We could have 2 quadratics that just never touch. We could have 2 circles that never touch. Quadratic and a circle. So these are all like examples that you could come up with. A circle and a line. Oops, that actually touched. So maybe we'll do it like this. Do a quadratic and a line. So there's lots of choices that could make this work. I'm trying to separate this a little bit. I think you get the idea. Okay, one solution. Could you sketch some things that only have one solution? Okay, I think I'm going to try and do this a little better by drawing these in first. All right, so we could do something where we have a line and a quadratic that just touches once. We could have a circle and a quadratic, so there's lots of choices. We could do a circle and a line. It's like a tangent line. We could have 2 circles that touch one time. 2 lines. Those will always either have no solutions or one solution. And we could have 2 quadratics. So lots of choices. 2 solutions could be something like a circle that and a line that cross. So here it crosses twice. A quadratic and a quadratic. A quadratic and a line. 2 circles. A quadratic and a circle. Okay, so those are all good examples. Infinite solutions would be things where we have lines that are on top of each other. So like a line on top of a line. Okay, now, that's not very exciting, or a circle on top of a circle. Okay, so they're just the same, exact same equations. Okay, those have infinite solutions. Can you think of any that have 3 or 4 solutions? 3 solutions could be something like this. Let's see if I can draw it really well. This would be really difficult to do. So like a circle and a parabola. Or 4 solutions could be something like this, where the parabola crosses the circle 4 times. All right. You could also even have systems of equations that have multiple, like 3 equations, like 3 lines that could all intersect. Okay. So this would be like a system of 3, or you can even do more, 3 plus equations. Okay. All right. So that's it. If you have any questions, please let me know. Hopefully this wasn't too bad. We'll see you guys.